Hi learners, welcome again to our Chemistry from 1 lesson. In our previous lesson, we talked about luminous flame, and today I want us to focus on the non-luminous flame. Now, non-luminous flame has 3 regions. The first region is known as pale blue zone. The second region is known as green-blue zone. The region here is known as almost colorless region. Luminous flame, we say that it has 4 zones. Non-luminous flame has 3 zones. We have pale blue zone, we have green blue zone, we have almost colorless zone. This flame is predominantly blue because the laboratory gas undergoes complete combustion in sufficient supply of oxygen, and therefore there is no unburnt carbon particles. It doesn't glow producing yellow light. It is predominantly blue because it is formed when the air is fully open. That is the condition. The air is fully open, and therefore the laboratory gas undergoes complete combustion, resulting to no unburnt carbon particles, and that is why this flame is normally predominantly blue. Again, this flame is very hot because the laboratory gas undergoes complete combustion in excess supply of oxygen. Comparing with the luminous flame is wavy and long. Non-luminous flame is short and straight. Luminous flame is less hot. Non-luminous flame is hotter, meaning it produces more heat as a result of complete combustion of the laboratory gas in excess oxygen. Non-luminous flame has 3 zones, namely pale blue zone, green blue zone, almost colorless region. Luminous flame has 4 zones: thin outer pale blue zone, bright yellow zone, almost colorless zone, and blue zone. Luminous flame produces soot. Non-luminous flame is non-sooty. The advantage of luminous flame is that it is visible. It cannot cause an accident in the lab more oftenly because the person or the student in the lab can easily see it. Non-luminous flame is less visible, and therefore when the learner is not keen, there can be an accident or fire accident. That must be noted. But sometimes we are told that once you are done with the non-luminous flame, it must be converted to luminous to avoid wastage of fuel because it burns in excess oxygen, utilizing a lot of fuel. Again, we can have this reason. Luminous flame is more visible, non-luminous flame is less visible. So we are told we convert non-luminous flame to luminous to avoid fire accidents. Again, we must know very well that non-luminous flame is produced when the air is fully open. That's the condition. Then luminous flame is produced when the air is closed. If you are told, what flame will you prefer for those experiments that require strong heating, you will prefer non-luminous flame because it produces a lot of heat. If you are told, which flame will you prefer to produce for lighting, we'll go for the luminous flame because it is formed when the laboratory gas undergoes in complete combustion, resulting to white, hot, tiny and burnt carbon particles which glow producing the yellow light, and that is why we prefer it. Learners, if you introduce a wooden plate here, actually through the almost colorless zone, we're gonna have it appearing like this. The middle part will be unburnt. The middle part will be unburnt because it is in contact with the almost colorless region with unburnt gases. The sides will be charred or will be burnt because they were in contact with the regions where we have the burnt gases. So this one can be a question in exam that you must understand. When iron splint is introduced into the almost colorless region, the middle part remains unburnt because in the almost colorless region we have unburnt gases. The sides must get burnt because they are in contact with the burnt, with the regions that have the burnt gases. If we introduce a small tube here, we are going to form a small flame at the end of the tube when the gases that come out there get ignited. Why? The unburnt gases in the almost colorless region, upon reaching at the other end, having passed through the tube, when ignited, produces a small steady flame. That is also another way to know that this region is a region of unburnt gas. You can use a small tube whereby we insert it there. The unburnt gases get to the jet. When they are ignited in oxygen, they form a small steady blue flame. Again, we can use a wooden splint which can be introduced into this region. The middle part becomes unburnt because it was in contact with the almost colorless region, a region of unburnt gas. The sides become burnt because they were in contact with the regions of burnt gases, and that is something that we need to appreciate. Thank you, learners, for listening to me. We have done the non-luminous flame, and we have also compared with the luminous flame. Stay blessed. See you then.